Hello. At the beginning, I have a question. Is there anyone who does not speak Polish? Okay, so I will continue in English. So, welcome everyone. I'm going to talk during those 45 minutes about architecture, about should the architecture be perfect, should be ideal, or should this architecture just be good enough? So the few words about me. On a daily basis, I work as a co-founder of the DevSkiller company. DevSkiller is a platform that helps companies to verify the technical skills, the technological skills of software developers, of system administrators. So if you want to check if someone is capable of doing some sort of technical things, you can use our platform to do that. So you can check if someone is able to blog application, extend it to add some new features, expose some REST APIs, use external dependencies, write tests, etc. I'm also working as a trainer in Bottega company. I'm a member of the program committee of DevOps Poland, and I'm active open source contributor after hours. And now I just want to introduce you our new open source project released like probably 1 hour ago. And it's a tool for Java to generate or to convert identifiers URL 62 or URL 64 friendly. So this ID is encoded as something that you see below, and it's a bidirectional conversion. Okay, so let's start. Salvador Dali said that have no fear of perfection because you will never reach it. And I will return to this sentence many times in this presentation. But first thing is that the other, let's say, subject of this talk could be what you can learn from a startup. Why? So for the last few years, I'm running my own company. But for the last 7 years, I've been working as a consultant in pretty big companies, including one of the biggest companies in Europe. And what I realized is that the big company have too big inertia to judge whether the results or what are the, let's say, effects of the applied changes. And if you have a startup, it's a small company, without such inertia. And in startup, everything is clearly visible from the very beginning. And I had a lot of observations made during the last 4 years, and I just want to share with you what was working, what wasn't working, and what we accidentally were able to achieve. So the first question is, does the perfect architecture in fact exist? So from Salvador Dali, we know that there is no something called the perfection. So when I ask this question on my trainings, what do you mean by the good architecture? There are a lot of different answers, and different problems brings people to different solutions, to different aspects of the architecture that are important for them. But I see that there are some commons. The commons to which are the most used are the pragmatic and tailored, okay? So that's usually something that's mentioned on all trainings in all different companies. The two things that are most important for me as an entrepreneur is that I want to get a fast feedback, and I want my architecture to be cost effective. Why fast feedback? Okay, because working in a company, working on a business side, means that you are almost always doing tries and mistakes. And that's okay, that's normal. Okay, and why should I keep the fast feedback? Because I want to get feedback from the market, from the users, as soon as possible. I don't want to finish giant project and then realize that no one wants to use it. I want to know that this project sucks at the very beginning, when I didn't spend on it a lot of money, okay? And why it should be cost effective? Because when I was working for giant companies with enormous budgets for IT. No one was asking, do we really need that feature? Do we really need that refactoring or something like that? And when you see the money, because this money is on your account and you can spend that money on a beer or you can spend that money on the refactoring, then you start thinking, should I do this thing? How should I operate and how should I use the technical debt? Okay? Should I care about the code quality in a project that will live for 1 week because it's used only to migrate data from the one database to second database? Should I really care about the quality? Should I care to move everything to properties? Do not use hardcode or something like that? Or should I just avoid it because I know that this debt will be very, very cheap? Okay? On the other hand, talking about this fast feedback, most organizations in the world say that, yeah, we are doing Agile. We believe in Agile. We are lean companies, etc. But then you realize, okay, so if most of the companies are doing Agile, why most of the companies ship new features to the production in months or in weeks? Yeah, we are a very lean company. We need 2 years from the idea to start a project to release the production version. So something is not working. Something is wrong. Why something is wrong? So in my opinion, a lot of companies are really seriously doing Agile. Okay? And we shouldn't do Agile, we should just be Agile. The difference is that we shouldn't focus on a Scrum, on Agile itself. Instead, we should just try to realize, why do we want to use Scrum? Why do we use Scrum on a daily basis? Okay? We are not using Scrum, we use Kanban because it's something that suits our needs. Okay? If you need to do something, just do it. Okay? And the problem is that in many companies, there are procedures that are needed just to have procedures. Okay? And I think that if the IT department is mature enough, it doesn't need business to operate at all. There are so many things that we can do. We can, I don't know, move to the newer version of libraries. We can do some refactorings, proof of concept, technological spikes. Let's automate some stuff. Let's move from Azure to AWS and then back to Azure and then to Google Cloud or something like that. Okay? We don't need to implement features to have a lot of work to do. And that's the problem, because we should remember that we are working in a company and this IT exists to solve the business requirements, to solve the business problems, not the technological problems that we are introducing ourselves. Okay? And what is important for me is, for example, that I really believe in continuous delivery. Why I believe in continuous delivery? Because continuous delivery is a key to fast feedback. And as you realize during this talk, it's a key to also a lot of other doors that we should keep open, because it helps a lot. Okay? But when you talk about the continuous delivery with the business side, they are afraid. They say, no, don't do that. We don't want to use the continuous delivery or the continuous deployment. And I was thinking, why? We use continuous deployment on a daily basis and it works great. So why you, the company that is really mature and really need this fast feedback from the company, because you need to be able to release some products before the competition, why don't you want to use the continuous delivery? And the answer is very simple, because IT, as well as the business, don't see the difference between the deployment and the release. Okay? And they are two totally different things. Because deployment is just a technical act of deploying new version of the software to a target environment like production. Okay? And what's the release? Release is much more than the deployment, because if I'm deploying the version, great, the new version is live on production. But what does it mean that I'm releasing the new version? It means that I'm exposing the new features, new functionalities to the end users. Okay? What's the difference? because I need to think about the documentation. I need to care about some marketing communication, maybe trainings, maybe webinars, maybe some screencasts, okay? Maybe posting news on Twitter, Facebook, etc. Okay, and that's obvious that business don't want to do it on a daily basis. Can you imagine the situation that business every day updates the documentation to be up to date? It makes no sense. So what can we do is that the technological departments care about the deployments, but the business side is the one who cares about the releases. So which not we want to deploy every day, and that's okay. But if business decide, okay, we want to release that feature once per 2 weeks or once per 2 months, that's perfectly okay. Okay, and it's still valuable for us. The biggest issue or the biggest challenge in implementing continuous delivery is to be sure that the new version is as good, at least as good as the current version. Okay, I don't want to introduce new bugs or new, I don't know, problems to the production if I'm releasing a new version. So what should I care about is regression. Okay, I must be sure that the regression is okay. The problem with regression tests is that regression is really expensive. If you consider the pretty big enterprise system, there could be thousands of tests using some tools like Selenium or something like that, just to ensure that the version is working correctly. And the problem with regression is that someone needs to maintain those tests, okay? And from my experience, probably like 90% of the failures of the regression tests are caused by the problems in tests, not in the production code. So someone fixed a bug, but he didn't fix the test. Sorry. Someone has changed some text label or something like that in the system. Oh, I forget to change the tests, so the pipeline is red. I cannot deploy to production. So if the regression is too expensive and I don't want to use a regression, I don't want to run like 8,000 acceptance tests every day, what can I do instead? So I can verify just the critical paths of my application. If I'm running an e-commerce portal, what's the most important stuff? That someone is able to add the product to the cart, is able to check out and pay for the... That's all. That are the critical paths of my software. But what about all other features? We have great testers on production, and they are for free. It's our users. Okay? So let your users, let them know you that some feature is not working correctly, that there are some mistakes, some errors or something like that. But there is a giant but in this statement. Okay? If you want your users to verify the application instead of you, you must be almost always sure that this application works correctly. How can you do that? By caring about tests, okay? Unit tests are really fast. They are really cheap. If you believe in test-driven design, you write unit tests, let's say by the accident. It's a side effect of the code, okay? Or the code is side effect of the tests. No one knows. So we really care about the unit tests. And that brings us to the situation when I know that if the application is compiled, if I have a jar that is ready to be shipped to the production, I'm almost sure that this application will work without any issues, okay? But if there is any issue that you just deploy to the production, you need to fix this issue really, really fast. By really, really fast, I mean that we are solving probably like 90% of the issues in less than 30 minutes, okay? So from the moment we or the user realize that there is a problem on production, it takes us less than 30 minutes to restart the last node on the production. How it's possible? Continuous delivery is the answer for this question. Why? Because if I'm releasing the software every day and someone tells me, okay, there is a problem that when I'm sending an invitation, something happens. Okay, let me check. Let's see what are the changes in the code around inviting candidates. Oh, since yesterday, there are 3 code. It's much more easier to analyze 3 commits with, I don't know, 80 lines that were changed, instead of verifying the 400 commits made by 50 people in the last, I don't know, 100 days, okay? So I'm able to find a bug really, really quickly because there is just a small diff of the code that I need to analyze to find a problem, okay? And then I just need to deploy the solution as soon as possible. How can we do that? So the way we solve it is to keep the microservices. Why do we use microservices? Because microservices are designed to be autonomous. So it's hard to not use autonomous releases in the microservice environment. Okay, every component is separated from the other. I can deploy this component instead of releasing the whole application. So I can do it without any downtime. My releases are not visible to end users just because I have autonomous microservices. Also, microservices are cloud ready, so it's easy to scale them horizontally. And the microservices are small enough to let us keep our deployment pipelines fast. What does it mean? If you have a big monolithic application, it takes like 40 minutes, 50 minutes, maybe more than an hour to build an artifact that can be deployed to production. If you have a microservices, then building an artifact that is ready to be shipped to production takes minutes. Okay? If you have strong machines on your continuous integration environment, it's usually like 2 minutes, 3 minutes to build the application running the unit tests. And that's great, because then I need to deploy it to the staging environment, run critical acceptance tests. But critical means that I'm able to run those acceptance tests in few minutes, maybe 5 minutes, okay? So from the commit that I've made, I need like 3 minutes to build our artifact, 1 minute to deploy this artifact into staging environment, 5 minutes to run the acceptance tests, and after 10 minutes, I'm able to deploy the new version to production. Okay? That's why we use microservices. And the best thing in microservices is the communication. Why? Because of the valid SLA, uptime of your services, as well as the correctness of this communication. And I can say that the communication in distributed environment is the root of all evil. When you take a look about on the SLA, and SLA is pretty easy. When you have one component, it's easy to say if this component is working or it's not working. And if you have microservices environment with 10 applications, maybe 100 different applications, when you say that my environment is working, do you need all microservices to be up and running, or just some critical ones? It's hard to decide. The biggest problem is that if you have 10 components with the SLA of 3 nines, the final SLA of the business process is 2 nines. Why? Because in the probability theory, those events are totally independent, okay? And independent events means that you need to multiply all probabilities, okay? So the problem with the communication in the microservice world is that more microservices involved in the business process, the lower uptime you can guarantee to your end users. There are, of course, some, let's say, techniques that we can use to try to cut those relations, like using the asynchronous communication, but it's not something that can be used everywhere, okay? We should use the asynchronous communication by default, but it's not something that can be introduced in any place of our application. If you need to respond to your users to some query, you need to use the synchronous communication because this user is synchronously waiting for the result, okay? So that's the SLA. What's about the quality? So how can I be sure that after releasing one component to production, this component is able to communicate with 5 or 10 other components? How can I be sure that the model is okay, that the fields are named the same way? So can I use the shared model? That's the easiest solution, but it's not working, unfortunately. Why? Imagine the situation. It was a situation that happened to us because I was really a huge fan of the shared model, canonical model of data, and it's not working at all in the environment that needs to be released without big release cycles. Why? Because imagine that you have a component that's the enum with customer status, but it ignores this field. This field just exists in the canonical model, in the shared model, in the customer representation. But I just need to read the name of the customer, email of this customer, okay? I'm adding a new status. I'm adding support for VIP components. But this enum value doesn't exist in the notification service, okay? I'm releasing the new version of the service that is sending requests to the notification service. What happens? 500. Exception. Cannot deserialize it. I don't have a VIP value in the customer status enum. Yeah, but you are not using this field. I'm a Jackson deserializer. I don't know which field should be used and which field shouldn't be used. It's a canonical model. So canonical model sucks. So what can we do else? We can use end-to-end tests. That's great, but end-to-end tests are extremely hard to operate in microservice environment. Why? Because it's hard to keep all components up and running on production, not talking about the staging environment. Also, how can you be sure if you are testing the fallback or a real implementation? Okay, you get the information that this customer can proceed with the order, but are you sure that you invoked the real anti-fraud service or just the fallback of the anti-fraud service because anti-fraud service is not working, it's not operating, or maybe it just can't read your request? You don't know. So maybe let's turn off the fallbacks on a staging environment. Great idea, but how are you going to test fallbacks? Okay, end-to-end test doesn't work in a microservices environment. So what can we do to solve the question? The answer is that we can use the consumer-driven contracts. What's the idea of the consumer-driven contract? So there is some very advanced mathematics which is saying that if A is equal to C and B is equal to C, it means that probably A is equal to B, right? I know it's hard, but try to focus, okay? And now, if we are able to use this relation in the programming field, it means that I can check if the service A is equal to its contract. Then, if service B is equal to the same contract, okay? How it looks like in practice. Let's say that I have a contract. If you invoke the GET request for the path added or something like this, with the request parameters 2 and 2, you will receive the status code 200 and the response body containing sum equal 4. Okay, that's my contract. What can I do now? So the first thing is that if I will invoke the GET query with such URL and such requests parameters to the real physical server, and if this server responds me with the request 200 and with the body sum equal to 4, I know that it's working correctly with the contract, right? What I can do on this client side, I can try to mock the server, okay? And this mock expects to receive the GET request for such and such URL with such parameters, and this mock or stub will respond with the 200 and body sum equal to 4. And then if I know that server is producing the same request that is defined in the contract, and I know that the customer is able to consume the same request that is defined in the contract, there is a pretty big probability that this customer, the client application, will be able to communicate with the server. And that's how it works. It's a test-driven design, but on the level of the architecture. If you're interested in this subject, and you should be if you are going to use the really distributed environment, there will be talk today by Jędrzej Andrzejkowski in 2 hours about the consumer-driven contracts. He will be talking about the Spring Cloud contract. It's the application that were developed by me and Marcin just to solve this one, because it's pretty old. It was defined by the never mind, like 10 years ago, but there were no good tools to solve that. And now the Spring Cloud contract is solving that great in the Java world. But how can we handle versioning in such environment? It's pretty easy. Just don't. Be always up to date. Why? Because if you are deploying every day, there will be a lot of versions. And it will be hard to define if someone is using this version, if someone don't use this version, can I remove this version or someone still rely on that? No, I just don't have versions. I'm using the deferred changes, which means I'm doing only the changes that are backward compatible for some time. Let's say 1 week, and everyone needs to be always up to date in 1 week, because if no, then sorry, that's your problem. Okay? But what happens with the performance? How can I be sure that deploying every day to production, I won't destroy the performance of my application? Maybe let's use the performance tests. But seriously, do you really want to execute the performance test on production every day? I don't think so. Okay? And the performance tests are even more expensive than the regression tests. And they are lying all the time on any field that you can use the performance test. Those tests are lying to you, especially if you're using such advanced technologies like JVM with a lot of optimizations made by JIT, dead code elimination, etc. Okay? So it won't work. So what instead? I can use, for example, the canary deployments. So I'm deploying just my application to one node, and I'm observing the metrics on that node. So what is the average response time on this node with the new version, and what's the average response time on other versions? Is it similar? Yes, okay. So let's roll out the application, because we are not breaking the performance. And to be honest, I think that the monitoring is the new testing. Why? because it's much easier to verify the performance on the production instead of, you know, just running and maintaining the performance tests all the time. Especially that performance tests should try to replay the production traffic. And production traffic, as the name happens only on production. Okay, so what do they mean about by the monitoring? I mean monitoring the performance of the application. We have tools called the APM, so Application Performance Management, like the New Relic that we are using on a daily basis. It's a great tool, but there are others like Dynamics, Dynatrace, etc. They are tools which are expensive, but they allow you to almost throw away all your performance tests and be able to solve it on that way. Also, the system health. I need to check if all my servers and all my applications are up and running. Also, when I allow my users to have, let's say, some tiny problems on production, which means I'm not verifying using acceptance tests all the features in my application, I should monitor if there are any strange things happening on production. In the 90% of the use cases, I know that there was a problem on production before the users writes to us using some intercom communication. Why? Because there was an exception, and this exception was reported to the Logstash, which was triggering the alert, which ends up in a Slack channel saying that, hey, there was such and such error on production. Okay, oh, it shouldn't be happening, let's solve it. And usually when customer tells us that there is a problem and he was trying to do something and there was some red screen with information that please contact the administrator, we usually say that we know and the fix is already being deployed to the production, okay? And that's something that you need to do if you don't want your users to be angry, okay? If I will have errors in my production code every day, then probably my users will say, screw you. I don't want to work with a system that has mistakes and everywhere I click, I get some error alerts, etc., okay? So we can do that because our unit tests are ensuring us that if there will be some problem on the production, it happens like once per 2 weeks. Some users reports us that something is not working, okay? If I have 2 emergency deploys per month, it's seriously nothing, okay? And even if it's, let's say, pretty big problem that someone is not able to clone the test because there are like random order of the pages, and we say that, okay, we know it will be fixed in 2 hours. They say, 2 hours is nothing. If something like this happens in our company, it takes 3 months to the fix. So they say, okay, no problem, I will do something else. Please just let me know if this will be fixed. If it will be tomorrow, then it's still okay. Okay? With metrics and with monitoring, there is something that is strongly related. It's metrics. And I see the metrics everywhere. Why? Because metrics allows us to use our normal approach to the solving problems, like the engineering approach, also to other fields like sales or the market, okay? Because metrics gives you the instant feedback. If you want to know what's happening to your application, what's happening to your, let's say, users, how your sales, okay, you can use data warehouses and you will know what was the status in the last December. Or you can use the metrics and you will know what's the status right now, okay? How many users were using your system in the last 5 minutes? How many requests were made in the last 10 minutes? How many trials were registered in the last 1 week, okay? What's the conversion rate from now to 30 minutes ago? And you know it live. Okay, so it's the live business intelligence. It allows you to build organizations that are data-driven. So you are just not shooting, I think we should do that. No, I don't think, I know we should do that because I see it in the metrics, okay? And data-driven means that I'm doing only the stuff which is valuable, okay? So if you will provide the metrics and the good metrics to your business, you help them a lot to decide what they should do. And by using the continuous delivery, you give them the ability to receive the fast feedback, which means you allow them to use the to use metrics to decide what to do and when to do. Okay, so the problem is that any action that we take is some kind of investment. If I want to solve a bug, then I'm investing in solving this bug. And I always should think about something that's called the return on investment, which means, should I really solve all these bugs? Should I keep the zero bugs policy? If there is a bug, and the cost of this bug is, let's say, $1 per month, and solving this bug costs me like $50,000. Should I fix this bug, or should I leave it? Okay? When I was working for the big companies, I wasn't thinking like that. There is a bug, I should fix this bug. Okay? When you see the money, you just start thinking, wait, should I fix this bug right now? And after running my own business, I was applying the same principles to the big companies that we've been working with. So they said, okay, we need to implement some such and such solution. Okay, so how much do you want to earn on that solution? What? Yeah, we are asking how much money do you want to gain on such functionality? Because we need like 100,000 zlotys just to analyze what we should do. Oh no, so we won't earn so much money on this feature. So maybe let's avoid it and do something that is more important to you. Oh yeah, let's think about it, okay? So we just starting thinking in the return of investment. Also, it's subject of something that is called the safe to fail, okay? There are two solutions. One is fail-safe, second is safe to fail. Safe to fail means that you will fail somewhere, okay? But you will. So if I know that there will be some problem, if I know that there will be exception, if I know that there will be some, I don't know, issue in production, I just need to care about the minimizing the impact, okay? So it won't hurt. Which means, for example, you can try to do everything to not let any bug enter the production environment. So let's implement the hundreds or thousands of tests. And let's have a pipeline that takes us like 2 weeks to validate all the stuff to be able to deploy it to production. But then the problem on the production occurs. What can you do? You can solve it in 2 weeks. Okay? And the safe to fail means, okay, I won't prevent all the bugs. So let's do it in the way that those bugs won't hurt. So I'm verifying the critical paths, and I'm able to deploy a solution or the fix as soon as possible to not let it grow. Okay? Also, I'm using the self-healing communication. I know that the communication can fail. Communication is failing all the time in distributed environments. But if I know that this communication it's safe to fail. I have communication that is idempotent. I can replay all the communication, not only get statements, but as well as post and put statements, because I know that it can fail somewhere and I need to replay it automatically, okay? Also, safe to fail means that I need to be notified about some problems or problems as soon as possible. It means that if there is a problem with such functionality, I can roll back this functionality really easily. For example, we are using tools, so feature switches. I'm introducing the functionality. I'm not sure it works correctly, so I use a feature switch, and I'm able to roll back this feature in like 10 seconds in production just by changing one checkbox in the administration panel. Okay? It also means that I need to eliminate our human errors. How? By introducing something that is called repeatability. How? By automating. Why? Because machines compared to humans are good in repeating tasks. I don't want to do the same thing all the time, every day. And my computer has the problem that it needs to copy one file from the one place to the other like every 10 seconds. It's okay. So it's generally to estimate use to the computer to do something, okay? And of course, the machines are much more cheaper in the repeating tasks. So what can I automate? I can automate tests, because if tests are automated, they're always validated on the same level. If the user is validating some test, if it's checking if some, let's say, the critical path is working, after 3 months, he will say, oh, this thing is working all the time. I don't want, it's always working. It's just a waste of time. And now it won't work. Computer won't say something like this. So also automate deployments. So I know that my deployments always work in the same way. I can automate the setup, okay? Which means if there is any problem with my machine, I can throw this machine away and configure it one more time in fully automatic way, okay? So I can also automate infrastructure. You need a load balancer? No problem, let's automate it. So in fact, it means that we are automating everything in our application, and that's true, because of course, the application source is a code. Everyone knows that. It's a Java source code, okay? But what about the build jobs? If I have a jobs on my Jenkins that are building my applications, can it also be a code? Of course. There is, for example, Jenkins job DSL that allows me to specify the deployment pipelines and put them into the repository. All deployment scripts, operating system configuration, etc. It also can be implemented in, I don't know, Ansible, Chef, or Puppet and keep in the repository. Okay? Properties of the application, setting up the infrastructure. If you are using a cloud, there are tools to automate the cloud deployment. You need to set up machines, not problem. You need to have 50 machines. Just change one integer from 10 to 50, and you have 50 machines on production, okay? So I'm automating everything. And now take a look at the funny things. I need backups. Why? Because I'm able to recreate everything. So everything that I need to backup is the code, okay? That's the obvious thing. I need to backup my Git, and I need to backup the data, okay? But no configuration, because I'm the master of the configuration. The configuration on the target environment was applied from the source code. If I have a source code, I don't need to backup the target environment at all, okay? So we are not backupping infrastructure, we are not backupping virtual machines, we are not backupping EDC directories, we are just backupping Git and data, and that's all, okay? So it looks like a giant cost to automate everything, and it is, but it's very solution to minimize this overhead by keeping order, which means just use the approach that is called a convention over configuration. What does it mean? If I need to configure everything, then it's something wrong. But imagine the situation that it's my example of some convention. I have a service that is called a service name, okay? Where is the repository for this service? It's acme.com repos service name.git. What's the artifact that this server is producing and should be released to production? Oh, it's target service name.jar without any versions. That's my convention. Where is the home directory for the application? It's OPT service name. Where are the logs? Logs are in the service name log service log. What's the Grafana dashboard? It's Grafana acme.com dashboard DB name of the service. What's the public IP of the load balancer of this service? Oh, it's Acme prod Western Europe name of the service public IP. What's the load balancer using this one? Acme prod Western Europe service name load balancer, etc. And now take a look. I don't need to configure if the load balancer should use the public IP address or not. Because if the public IP address exists, it means I've created it, use it. So please, dear load balancer, use this one. It's the same approach that works, for example, in Spring Boot, when just adding a dependency is enough to know, let Spring know that you want to use it. You've added the MySQL dependency, it means that probably you want to use the MySQL because that's why you put the dependency here. The same applies here, okay? If you introduce the load balancer, it means that you want to use it. If you introduce the IP address, it means you want to use it, okay? And all this thing means I'm keeping my architecture good enough. It's not perfect. There is a place for mistakes, there is a place for bugs, there is a place for, I don't know, errors in communication. There is a place to introduce some small performance degradation, but it's still good enough. So what are the most important takeaways from this presentation, in my opinion, is that we are able to introduce the monitoring of our platforms really, really easily. Like introducing the new relic into the system takes like maybe 1 day. You just need to add the Java agent and it works. So introducing some other, like the drop wizard metrics or something like that, it's few days to introduce it into the application. How can we automate jobs? It's also, it's not a giant task. It's something that you can do in 2 weeks, okay? If you need to conventions, that will be really, really easy. So let's start from the convention that if there is an application with the name X, the artifact of this application will be x.jar. That's the great convention, because then for all applications in your system, you don't need to configure what's the name of the artifact. You know it, because you have a function instead of the value, okay? We talk about the functional programming all the time, so why don't we use the functional approach on a daily basis, okay? Just replace the properties with the functions, and then you will be ready to introduce the continuous delivery. Maybe not continuous deployment. Maybe you won't deploy your application every day to the production, but just go to the place where you can go to the business and say, okay, so we ship every day application to the staging environment. You can every day verify if this application works correctly, and if you will decide that you want to deploy this application to production, you can do that. Okay? And that's all. If you have any questions, we have no time to do it right now, but I will be here for the probably like until the next presentation, so don't hesitate to ask me. Thank you for your